Have you ever wondered how a dog can follow someone's trail days after they've passed by, as if reading invisible pages scattered across the environment, or how a male moth finds a female from miles away, guided by signals our senses simply can't detect? While we rely primarily on sight and hearing to interpret the world, many animals live immersed in a universe ruled by sense, chemical trails, and invisible messages that reveal complete stories about who was there, what they felt, and where they went. Every human step leaf behind a silent chemical trace, every emotion alters the composition of sweat, and every physical contact spread tiny clues that animals can decipher with astonishing precision. For them, smelling isn't just about detecting odors, it's about understanding intentions, emotions, and complex social dynamics that shape survival decisions every single day. Animal olfaction works like a sensory lens, revealing threats before they become visible, opportunities before they're perceived, and social connections even before any direct interaction occurs. Today we're going to explore this hidden chemosensory world and discover how life on Earth is deeply influenced by a silent language we rarely notice, yet one that sustains social relationships, evolutionary strategies, and fascinating behaviors unfolding all around us. Animal smell goes far beyond simply identifying food or immediate danger. It functions as a powerful communication tool, transmitting detailed information about identity, social hierarchy, and emotional state. Many animals recognize individuals solely by scent, distinguishing family members, rivals, and potential mates with a level of accuracy that challenges our understanding. In natural environments, scent marks act like invisible signposts that define territories and prevent direct confrontations, allowing species to coexist without constant conflict. Over evolutionary time, the ability to detect complex odors dramatically increased survival chances by enabling animals to locate hidden prey, find water in arid regions, and sense predators long before any visual or auditory cues appear. Hormonal changes also release chemical compounds that signal reproductive readiness and major physiological shifts, turning the environment into a silent but highly efficient communication network. Scientific studies show that dogs can detect variations in human emotions through the scent of sweat, identifying chemical patterns associated with stress, anxiety, and calmness. This means your pet often perceives your emotional state before you're even aware of it yourself. What seems to us like a fleeting smell can represent, to an animal, a rich narrative guiding essential behavioral decisions for survival and social interaction. Among the most fascinating mechanisms of animal olfaction is the vomeronasal organ, a specialized system designed to detect pheromones and extremely subtle chemical signals. This organ complements traditional smell and greatly expands communication between individuals. It allows animals to interpret messages related to reproduction, social dominance, and the presence of threats, creating an invisible layer of information that shapes complex group interactions. Snakes, for example, use their forked tongues to collect chemical particles from the air and ground, transferring this information to their sensory system and building a three-dimensional chemical map of their surroundings. Cats, on the other hand, rub against objects and people to deposit scent molecules that signal territory and belonging, creating silent communication networks that define social bonds in safe spaces. Pheromones also signal reproductive availability, ensuring encounters happen at the most biologically appropriate time, while reducing conflict between competitors. In moments of danger, fear-released chemical compounds can quickly alert group members, triggering collective responses such as fleeing or defense. These chemical whispers often replace vocalizations and help animals avoid unnecessary exposure to predators, showing that much animal communication occurs at a molecular level, invisible to human perception. Smell is not exclusive to mammals and plays essential roles across nearly all animal groups, from marine creatures to insects and birds navigating complex environments guided by subtle chemical cues. In the oceans, fish detect incredibly diluted chemical substances to locate food, recognize predators, and even find their way back to breeding grounds after years of absence. Some species can identify their natal waters through specific chemical signatures, demonstrating a remarkable olfactory memory that guides long-distance migrations. Among insects, highly sensitive antennae function like portable chemical laboratories, capable of detecting molecules associated with mates, flowers, and food sources. A male moth can follow a chemical trail for miles in search of a female, responding to signals so faint they're dispersed by the wind. Bees combine scent cues with spatial memory to locate flowers and share information with the hive. For a long time, birds were believed to have a weak sense of smell, but modern research shows that vultures locate hidden carcasses and albatrosses navigate vast oceans using invisible scent currents. Each animal group has developed its own way of interpreting the aromatic symphony that composes its environment. Human understanding of animal olfaction is driving technological and medical breakthroughs that are transforming how we detect threats and diagnose disease. Detection dogs can identify explosives and illegal substances with accuracy that surpasses many electronic devices, thanks to the extreme sensitivity of their olfactory systems. Recent research shows that some dogs can detect chemical compounds associated with cancer, enabling early diagnoses that save lives. Others are trained to recognize metabolic changes related to diabetes and alert their handlers before dangerous symptoms appear. Inspired by these natural abilities, engineers are developing electronic noses based on biological principles that promise to revolutionize agriculture, medicine, and environmental monitoring. Biomimicry reveals that evolution has already created highly efficient systems we can adapt to expand our own sensory capabilities. By studying animal olfaction, we not only gain a deeper understanding of nature but also open the door to technologies capable of detecting pollutants, identifying contaminated food, and monitoring ecological changes on a global scale. When we understand the central role of smell in animal life, everyday behaviors take on new meaning, and we develop greater empathy for the sensory experiences of other species. A dog intensely sniffing a lamppost isn't just being curious, it's reading detailed information about who passed by, when they were there, and what emotional state they were in. Animals live immersed in a constant flow of chemical data that we completely ignore, which means many human interactions may feel invasive or confusing to them. Allowing dogs to explore scents during walks stimulates the brain, reduces stress, and promotes deep emotional well-being. Understanding olfactory signals helps us interpret emotions and intentions, prevent conflicts, and strengthen bonds between humans and companion animals. This awareness expands our ability to respect the unique way other species experience the world and invites us to slow down and observe behavior from a more sensitive perspective. By recognizing that animals perceive dimensions invisible to us, we develop more conscious communication and build relationships rooted in understanding and mutual respect. The planet we share is crossed by silent language made of invisible molecules carrying stories, emotions, and signals vital to animal survival. For many living beings, smell isn't just an extra sense, it's the central axis organizing memories, social relationships, and decisions that define their very existence. Every chemical trail is a living message that connects individuals and turns the environment into a dynamic map of opportunities and dangers. When we grasp this hidden dimension, we realize that animals don't live in a simpler world than ours, but in a sensory reality far deeper and more complex than we ever imagined. Perhaps the future of interspecies communication lies in our ability to interpret these silent chemical languages that have always surrounded us. If this video expands your perspective on the incredible ways animals perceive life, keep exploring with us the scientific mysteries that connect humans and other species. Subscribe to the channel, join our upcoming journeys, and allow yourself to discover how every animal carries within it a unique and fascinating way of experiencing the world.